This video is going to be Chapter P, Section 4, Part 2, where we're going to be discussing addition and multiplication of polynomials. First thing we want to talk about is adding polynomials. So here are two polynomials, 8x cubed plus 3x plus 5 plus the quantity minus 3x cubed minus x squared plus 12. Notice how each of these individually are polynomials. So this is a polynomial, and this is a polynomial. What we're going to be doing is adding those together. So first thing we notice is that we actually don't even need these parentheses. We would need them if there was a negative sign here, if they were being multiplied together, or some other operation was being performed. So let's first write this without the parentheses. Plus minus 3x cubed minus x squared plus 12. Now, the way we add these polynomials together is I like to start at the first term. So 8x cubed is my first term. Now, the degree of this is 3, and I like to look, are there any other terms that have degree 3? Well, sure enough, here's one. And what I'll do is I'll add 8x cubed to minus 3x cubed, yielding 5x cubed. And every time I do that and I take care of one of these terms, I like to cross them out. So next up, I'll look at 3x. X is my variable, has an exponent of 1. So I look through and I ask myself, are there any other terms with the variable x and a power of 1? Well, no, there's not, so I'm just going to leave 3x alone. Took care of that one. Next, I have a constant term 5. Are there any other constant terms to add to 5? Yes, 12. So plus 17. Cross those out. Now all I'm left with is minus x squared. Okay? So adding like terms is how we add polynomials. The last thing we might want to be concerned with is just rewriting this polynomial so it is in standard form. That is, again, so that it is, the monomials are in decreasing order. Another example. So we have, it looks like polynomials of more than one variable. Now we can for sure add these together or subtract them, which it looks like we're doing. In this case, I do need to be concerned with this parentheses here and here because I have a negative sign out front. What I need to do is I will distribute that negative onto each term inside the parentheses. And to do that, what I'll do is I'll change the sign of each term inside that polynomial. This first polynomial, the parentheses I don't need, so I'm going to drop them. And again, I'm distributing the negative, so I'll change the sign of each term inside the parentheses. Notice it ended up becoming plus 3 at the end. And I'm just going to follow the same procedure that I did in the last example, starting with 8xy. Are there any other terms in this polynomial that have xy? There's not, so 8xy stays by itself. Next term, 3x squared. Are there any other terms with x squared? Yes, there's one here. There could be more than just the one. And 3x squared minus x squared leaves me with plus 2x squared. Crossing those ones out. Minus 2 plus 3 plus 1. Cross those out. Next term, minus 3x. Is there any other terms with x? No. Minus 3x. And lastly, minus y. Now, a good habit of crossing these out is then I know that I've taken care of every term. Now, since this is a polynomial of more than one variable, there's not really a nice standard way for us to rewrite this expression. So we're going to leave it as it is. Next up, we're going to be talking about multiplying polynomials. We have two examples. We have x times x plus 1 we have x plus 1 quantity times the quantity x plus 2. Now, remember in the last example when we were dealing with that negative outside the parentheses and we distributed that into the parentheses? We're going to do that same thing here in this first example. We're going to distribute the x inside the parentheses, meaning we're going to multiply every term inside the parentheses by x. So I'm left with x times x plus 1 times x. And we know that x times x is x squared, and 1 times x is just x. How do we deal with this new example? Well, I'm pretty sure everybody has heard my favorite F word, FOIL. The FOIL method is F. You're going to multiply the first terms together. So there's my F piece. That gives me x times x. The O is for outside. So I'm going to do x and 2. I is for inside. So I'm going to do those two. Plus 1 times x. Last, I'm going to multiply the last two together. So plus 1 times 2. Now I'm going to simplify this expression, giving me x squared plus 2x plus x plus 2. And one last simplification, x squared plus 3x plus 2. So hang on to that FOILing method. It's going to be useful. More multiplication examples. The quantity 2x plus 1 squared. Remember, when we square something, what we mean by that is we multiply the expression by itself the number of times the exponent indicates. So this is 2x plus 1, and since we're squaring it, we're going to multiply it by itself once. Okay? I do want to note this is not the same as 2x squared plus 1 squared. This is called the freshman's dream. You'll notice when we do this that the proper method and the incorrect method, they won't turn out the same. So again, referring to our FOILing method, my first term is 2x times 2x. O gives me plus 1 times 2x, Inside gives me 1 times 2x, and last gives me 1. One more simplification here. We'll get 4x squared plus 4x plus 1. And notice that these two are not the same. So be careful of that. That's a common mistake we make in this class. Getting a little more complicated, we now have 2x minus 3, quantity, times x squared plus 2x minus 2. Now, we can't exactly FOIL this one because there's not two polynomials of degree 1 multiplied together. Here we have a polynomial of degree 2. But we can go ahead and use the distributive property like we did in the previous example. We'll take 2x, we'll multiply it by everything in the second set of parentheses. We'll also take the second term, minus 3, and multiply it by everything in the second set of parentheses. Oops, should be a minus 2. Now we know that we can go ahead and distribute the 2x into the parentheses and do the same with the minus 3. So we get 2x cubed plus 4x squared minus 4x minus 3x squared minus 6x plus 6. And remember, when you're distributing this 3, it has a negative in front. So you need to change the signs when you're distributing. Like when we did minus 3 times minus 2, we got positive 6. Now, last little bit is combining like terms and simplifications. So, is there another x cubed term? Nope. Just rewrite that one, 2x cubed. Look for x squared terms. There's 1, 2. 4x squared minus 3x squared is plus 1x squared. Cross those out. Minus 4x minus 6x is minus 10x. And plus 6. Notice this one is in standard form already, so we are good to go. One more example of multiplication. A little more complicated than the last one, but remember when we had one term multiplied by a polynomial with 3 terms, we distributed the x squared and the 3x on and simplified further. We can do the same thing here, we'll just have to do it 3 times. We'll do x squared times this term, so x squared times x to the 4th minus 2x plus 2. Do it with 3x, so plus 3x times x to the 4th minus 2x plus 2. And last term we're going to need is plus 1 times x to the 4th minus 2x plus 2. And I'm going to let you go ahead and simplify that one a little further. And we'll finish up the last example. Wrong way. Alright, so here's a good fun one. What we have is we have a mixture of multiplication of polynomials and addition and subtraction of polynomials. So let's look at this first one. This term is, we're going to multiply it out using the foiling method, but we could also notice that this is a special product. If you look in the class notes, there's a list of special products that we can use, and we will actually be able to identify that this is going to turn out to be x to the 4th minus y to the 4th. Foiling out the next term, we get minus the quantity x squared y, so that's my f. I'm foiling again, remember I just have 2 polynomials, each 2 terms. So I do x times xy, then I do outside, I get plus x times y cubed, that's my outside. My inside is 3 times xy. My last is 3y cubed. And tell me, what is anything raised to the 0 power? I hope you said 1. You know, we may think there's a lot of work, there may be some more work to do with this term, but anything raised to the 0 power is 1. Now we come back and work on our simplifications. So x to the 4th minus y to the 4th. We want to distribute the negative in, minus x squared y, minus xy cubed, minus 3xy, minus 3y cubed, minus 1. Now we want to see if there's any like terms that we can combine. Are there any other x to the 4th? Nope. Are there any other y to the 4th? Nope. Are there any x squared y? Nope. xy cubed? Nope. xy? No. Y cubed? Nope. And no other constants.